Hello dear viewers, in this video we will get acquainted with analysis of batteries using the example of analysis ACK100.24.650.1. The devices are designed for testing accumulators and storage batteries of any type, supercapacitors, supercapacitors modules, galvanic cells, fuel cells, Redox batteries and any other sources and storage of energy. The analyses combine a programmable power supply and a programmable electronic load, and are available in various modifications. Each type of device has three main parameters: the maximum charge and discharge current, the maximum voltage on the tested battery, and the maximum charge and discharge power that the device can provide. For example, the ACK100.24.650.1 analyzer allows you to charge and discharge the tested batteries with a maximum current of 75 amps. The maximum voltage on the tested batteries can be 56 volts, and the maximum power that the device can give when charging or receive when tested battery is discharged is 1750 watts. The battery is connected to the analyzer for testing in a voltage drop compensated circuit using two current and two potential contactors. In addition, each device is equipped with an external temperature sensor, with which the temperature of the tested battery can be measured. If the charge-discharge current or the power that can be provided by one analyzer is not enough, the devices can be connected in parallel. In this case, the current and power increase in proportion to the number of the devices operating in parallel. For example, for analysis ACK75.48.1750.1 can provide a charge-discharge current of 300 amps and the maximum charge and discharge power of 7 kilowatts. The devices are controlled through a special application installed on the user's computer. The device and computer are connected directly or through a local computer network. The operation of the devices is configured by the user before starting the battery test, and is carried out according to a program that contains up to 3 test preparation steps, performed once, up to 42 steps in the cyclic part of the program, performed a specified number of times, and up to 3 test completion steps, performed once before the end test. For each step of the program, you can select any of the available operation modes, which include charge at constant current, charge at constant power, charge at constant voltage, discharge at constant current, discharge at constant power, discharge at constant resistance, discharge at constant voltage, rest, voltage scanning, current scanning, power scanning, resistance scanning, current pulses mode, power pulses mode, resistance pulses mode, current spreadsheet mode, power spreadsheet mode, resistance spreadsheet mode, or a voltage logger at the battery terminals. The cyclic part can be performed over 1,000,000 times, which is important when testing supercapacitors. In the step of charging with constant current, the device stabilizes the given charging current. The end of the step is performed when the specified final voltage is reached, after a specified time, or when a negative voltage increment occurs on the tested battery. At the step of charging with constant power, the device stabilizes the specified charging power on the tested battery. With an increase in voltage, the charge current will drop so that the power on the battery remains equal to the specified one. The charging step at a constant voltage is designed to keep the voltage at a given level with the falling charging current, which allows, for example, to organize the CCCV mode of battery charging. At the step of constant current discharge, the device takes from the battery a stabilized current of a given value until the voltage drops to the required value or for a given time. At a constant power discharge step, the device takes a given electrical power from the battery. When the voltage drops, the current will automatically increase to maintain the required power value. At a constant resistance discharge step, the analyzer simulates a resistive load with a given value of electrical resistance. With a decrease in voltage, the current consumed from the battery will also decrease, so that the ratio of voltage and current remains equal to the specified one. The constant voltage discharge step is designed to hold the voltage at predetermined level after discharge. In this mode, the device simulates a powerful Zener diode with a given stabilization voltage. The rest step can be used as a pause in the test for a given time. At the voltage scanning step, the device changes the voltage across the tested sample from the initial voltage U1 to the final voltage U2 with a given scanning speed. A sequential combination of two such modes can be used to study sample by the method of cyclic voltammetry. At the step of the current scanning, the analyzer changes the current through the accumulator from the initial current I1 to the final current I2 with a given speed. The current I1 as well as the current I2 can be either positive, that is the charge current, or negative, that is the discharge current, or it can be zero. At the step of power scanning, the device will change the power on the battery from the initial preset value P1 to the final value P2 with a given rate of change. The resistance scanning step can be used to change the resistive load on the tested battery from the initial value R1 to the final value R2 with a given speed. At the step of current pulses, the analyzer supplies alternating current pulses of the set value I1 and I2 through the battery under test, with the current I1 being supplied for a given time t1 and the current I2 being supplied for a given time t2. The current I1 as well as the current I2 can be either positive, that is a charge current, or negative, that is a discharge current. In any combination, the mode will be terminated when the specified voltage is reached or after the specified duration of the mode. At the step of power pulses, everything is the same, only the device delivers pulses of power of a given value to the battery under test. At the step of impulses of resistance, the analyzer acts as a resistive load with alternating values of resistance R1 and R2 during the time T1 and T2. A separate class of modes is work according to the tables of current, power, or resistance. In these modes, the analyzer operates according to pre-prepared and selected tables, which should contain two columns. The first column is time, the second is given current, power, or resistance, which should be at this time. Using these modes, you can simulate the operation of the battery in an electric car when the car is moving, for example in an urban driving cycle or in any other. Working at the tables of current, power, and resistance will also be useful for simulating the operation of the tested energy storage unit as a part of solar installations, wind turbines, as well as part of any systems in which the change in current, power, or load resistance on the battery occurs according to complex patterns. At the step of working according to the current table, the device works out in time the specified table values of the current. The end of the step occurs when the execution of the specified table is completed, or when the voltage on the battery decreases or increases to the specified voltage thresholds. At the step of working with the power table, the analysis works out in time the specified tabular power values. At the step of working according to the resistance table, the resistance of the load on the battery changes in accordance with the specified resistance table. The step of voltage logger can be used to measure the voltage across the battery terminals. In the logger mode, the power circuit of the device is not used, which provides a high input impedance of the device and small effect on the tested battery. By combining various testing modes, it is possible to create conditions for the tested battery that are as close as possible to specific conditions of its operation and to determine the characteristics of the tested battery in these required conditions, as well as to identify its actual resource. An important advantage of the ACK analyzers is the ability to measure the equivalent series resistance of the battery under test. Measuring ESR using the device can be carried out in several ways, the most accurate of which is the method of interrupting the charge and discharge current with a specified period and for a specified time. In addition, the ESR of the battery is measured at the moment of changing the current, power, or resistance in pulse modes, as well as when changing the steps of the test program. The end result of the analyzer's work is the text files with measurement results. The device stores two types of results files: several primary data files, one for each executed program cycle, and one general file of summary measurement results. Primary data files contain instantaneous values of voltage, current, and temperature on the tested battery with the specified step of fixing parameters in time, as well as instantaneous ESR values measured during charging or discharging. In addition, the primary data files contain the returned or received capacity in amp-hours and the returned or received energy in watt-hours, cumulatively from the beginning of the step. The primary data files can be used to build graphs of the charge-discharge of the tested battery, identify the capacity and energy stored in the battery in a specific voltage range, build graphs of cyclic voltammetry, graphs of changes in the ASR of the tested battery during its charge and discharge, and much more. Measurement summary files contain processed data, and each line of such file describes summary parameters calculated by the device for a whole step or for a whole cycle. The lines of the file of summary measurement results contain the total duration of step or cycle, the final voltage on the tested battery, the final current throughout it, the average temperature of the battery per step or per cycle, the average ESR value per step or per cycle, the total returned capacity, amp-hours, the total returned energy, watts-hours, measured capacitance in farads, ESR value measured at the beginning of charge and at the beginning of discharge, average leakage current per cycle, as well as the efficiency of the tested battery in terms of charge and in terms of energy. According to the files of summary measurement results, graphs of changes in the parameters of the tested battery can be built depending on the number of charge-discharge cycles passed or on the battery temperature, which is very convenient for life and temperature tests. The analyzers are controlled using specified software installed on the user's computer interface YP1. The test program for the battery under test is configured on the tasks page. Here you need to select and configure the testing mode for each step of the program, set the number of cycles for repeating the cyclic part of the test program, enter protective levels for limiting voltage, current and temperature for the tested battery, select the necessary modes for saving data to the measurement results files, enter the name of the tested battery, select path to the files for saving measurement results, and start the test with the Start button. Tables for modes of operation by tables are selected and configured on the Tables page. Here you can select the individual table files for the operating modes according to the current, power and resistance tables. The time and range of the parameter in the table, if necessary, can be adjusted in accordance with the required coefficients. The Graphs page displays graphs of the charge-discharge of the battery under test. Here you can select and see in graphical form the change of parameters on the battery in various combinations. For example, voltage and current, voltage and power, voltage and discharge resistance, ESR and voltage, ESR and current, and a number of others, as well as special display modes, for example, the dependence of current on voltage, which is convenient for monitoring testing in voltammetry mode. The results page allows you to observe the formation of measurement results files, the final form of which will be available to the user after testing is completed. The analysis page is designed to display graphs of changes in the characteristics of the tested battery depending on the number of charge-discharge cycles passed or depending on its temperature, and allows you to visually observe the degradation of characteristics during live tests. On the Settings page, settings are made for connecting to the analyzer or the several analyzers during your parallel operation. The Status page provides detailed information about the analyzer's operation and about various emergency events that may occur during the test. YP1 software also allows you to open and view results files obtained earlier, in the past, and saved on a computer, with automatic creation of charge-discharge and degradation graphs based on data from historical files, including in offline mode, without connecting to the device. The analyzers have a built-in memory designed to save measurement results in the event that the communication with the computer becomes temporarily unavailable. And the next connection resumption, all the accumulator data are transferred to the computer and saved to the files of measurement results without interrupting the operation of the device. This allows the device, after starting the test, to work autonomously for some time, without a permanent connection to the computer. In case of long-term live tests, this operating mode allows you to turn off the computer at night or even on weekends and holidays. ACK analyzers are a powerful tool for testing and analyzing the characteristics of various chemical current sources, and are designed to operate continuously and without interruption for months and even years. You can get acquainted with the devices in more detail. Download the PDF version of the operating manual, view and test the software for the device on our website www.battery-analyzers.com, the link to which is in the description. Thank you very much for your attention.